Hello, and welcome to Calculus Lesson 143. We're almost there, guys. After this, 5 lessons left, and then no more Saxon. You made it through all of the books. Congratulations, it's so cool. Today we're going to talk about the binomial series, or the binomial series, if you want to pronounce it that way. The idea is this. When we have 1 plus x to a power, if b is a finite number like 3, we can write out all the terms and we're set. We could just add them. But as b becomes larger and larger, or in fact possibly infinite, we want to find other ways to address this. How are we going to do this? Well, we're going to want to approximate this using a polynomial. So I'm going to use the Maclaurin series for 1 plus x to the b. Now, this is one that you will have to memorize eventually. I think, no, that would be horrible. No, you might get off the hook on that one. Okay, anyways, so let's find the Maclaurin polynomial. So we do n 0, 1, 2, 3, 4. The nth power of n, or the nth derivative of f with respect to x. So that's going to be b 1 plus x, and plugging in 0, we get b. Now, when we take the derivative of this, ooh, that's much better. Don't you think? Much better. So, it doesn't depend on what b is. When I plug in 0, I still have 1 to a power. Now, when I take the derivative of this, I have b times b minus 1. 1 plus x to the b minus 2. That's fine. Let me make sure I'm doing it correctly. We are. Now, I'm going to plug in 0 to this, and I get b minus 1. Now, if we take the derivative again, we get b minus 1, b minus 2, 1 plus x to the b minus 3. So this is b minus 1, b minus 2. And it goes on and on and on. In fact, if I go to the nth term, I know that I'm going to have these guys coming out here all the way down until so I'll have b minus n minus 1. Right? When n was 0, let's undo that. When n was 1, I had b and then b minus 1. So let's just do b minus n. There we go. Looks like the book overcomplicated this. They did b minus n minus 1. All right, I made an error. What is my error? I don't know. All right, I'll take at least 4 seconds to figure it out, and if not, we'll just have to live with it. I feel like it's b minus n minus 1 as well. Well, let's write out the third term. Maybe that'll illuminate our lives. So we have b minus 1, b minus 2, b minus 3, 1 plus x to the b minus 4. So you are going up to, b minus n term. So I'm going to disagree with the book, and I'll probably figure out why later, and then add it in the comments. So from there, we are going to do the following. That's why it's n minus 1. Okay, cool. It is n minus 1. I'll show you why in a second. Anyways, it's because you have 1 less term. So this one has 1, this one has 2, this one has 3. But n is 2, so you should have n minus 1 terms. That's weird. Anyways, so if I write that out as a Maclaurin polynomial, we had a little brain fart there. That's going to be b, so I'll say f of x is approximately b x to the 0 over 0 factorial plus b times b minus 1 x to the 1 over 1 factorial plus b minus 1 b minus 2 x to the 2 over 2 factorial, all the way up to this nasty term. We have b b minus 1, b minus 2. I'm off by a factor. Huh. This is why we're off by 1. So I took the derivative and put it here. So this is actually 1. Good catch. So our first term is just this when you plug in 0, which is 1. So I should have a 1 here. Then b. There we go. It's like the book's always right. Okay, so now we're going to go all the way up to, sorry for that brain fart, everybody. All right, so our 0 term has 1 as the coefficient. Our first term has b as the coefficient. Our next term has b times b minus 1 as the coefficient, all the way up to b times b minus 1. And you always want to look for a pattern here. The pattern is going to give you that last term that you could potentially add up to. b minus n minus 1. X to the n over n factorial. So this goes on for a very, very long time. Now, what we want to do is we want to now use this approximation for 1 plus x to the b to approximate the square root of 1.25. 125. How am I going to do that? Well, 1.125 looks like 1 plus 0.125 to the 1/2 power. This is 1.125. The 1/2 power gives me the square root. So that means b is going to be 1/2. X is going to be that. Not really a problem. Well, it is a math problem. But anyways, so what we do from here is that we are going to approximate this. Now they say they want an error of less than 0.001. So we have to note here that we're going to end up with an alternating series because b is less than 1. So we have positive, negative, positive, negative, and so on. And so you can find your error by using the next term. So let's write out some of our terms. Well, we have 1 plus b is 1/2, x is 0.125 over 1 plus this term here, b is still 1/2, but now we have negative 1/2 because 1/2 minus 1 is negative 1/2. 0.125 squared. Notice that x is not 1.125, it's just the 0.125. All over 2 factorial. And we're going to keep going until we find that term. It turns out you only need 3 of them. 1, 2, 3 terms to get within the error you need. So this is 1. This, remember, 0.125 is like 1/8, if I'm not mistaken. Yeah, that sounds about right. So this is 1 plus 1/16 minus 1/512, which is 1.0605. Now, if I find the next term, which is 1/2, negative 1/2 times b minus 2, so that would be negative 3/2 times 0.125 cubed over 3 factorial. This is my error because I have an alternating series. So with all of that stumbling on my words, that is problem set 143.